All right, so again, we're going to start conics in chapter 9. Today is circles and parabolas, and then we'll do ellipses tomorrow, and hyperbolas will follow after. So what is a conic? A conic section, which we simply call a conic, is an intersection of a plane and a double-napped cone. So the double-napped cone is what you see on the right there. It almost looks like an hourglass shape. It would be two cones turned with their nose put together. Okay, and each of these different kinds of conics is the result of a plane intersecting with that double-napped cone. So if it intersects horizontally, then it creates a circle, which would be equally round, right, from the same point in the middle. An ellipse is done if a plane slides like diagonally through, but entirely through both sides. It forms an oval, which is what an ellipse is. A parabola comes where it's slicing through maybe the top or the bottom of the cone and then one of the sides. And we're going to talk about a lot of that today, which we've obviously talked about parabolas before. And then hyperbolas are basically if you take a plane and slide it through vertically, it forms the hyperbola, which is two parabolas facing outwards from each other. So again, today we're going to talk about the circle and the parabola, but we'll eventually get through all four of these. So the circle is the collection of all points x, y that are equidistant from a fixed point, hk. And the standard equation, which we have seen before, is x minus h squared plus y minus k squared equals r squared, where hk is your center and r is your radius. So if you wanted to keep a note of all the equations you need to know for chapter 9, this is going to be the first of many. All right, so again, hopefully review, but we start with this. The point 1, 4 is on a circle whose center is at -2, -3, is shown in the figure. Write the standard form of the equation of the circle. So we just said that the standard equation is x minus h squared plus y minus k squared equals r squared. And to do this, we need the h, the k, which is the center, and we need the r. So what pieces of information do I already have? I have the center, right? This is my center, the -2, -3. What am I missing? The radius, okay? What's one way to find it? I can use the distance formula. So the distance between that -2, -3, and the 1, 4 will give me the center. Or sorry, the radius. So distance, which is also a formula you need to know, square root of x2 minus x1 squared plus y2 minus y1 squared. So I can use either point as my x1 and my y1, or my x2 and y2 as long as I'm consistent. So let's say that these are my 1s and these are my 2s. I would get -2 minus 1 squared plus -3 minus 4 squared, -3 squared, -7 squared, which is the square root of 58. So that represents the distance from the center to the point on the circle, which is also your radius. So if I was to ask you for what the radius length was or what the distance was, I would expect you to take that square root of 58 and simplify it, right? Like break it down into its factor tree until you could simplify it. But what are we doing to that radius when we put it back into the equation? Squaring it. So when you square a square root, what happens? It just cancels out. So you'd either have to simplify and then square the simplification, which is double the work. You can just leave it as it is. So right now I already have enough information. I would have my x minus a -2 becomes +2 squared, plus y minus a -3 becomes +3 squared equals the square root of 58 squared, which is 58. What's the other way you could do this?
You could plug everything in like the 0.14 and the center into the equation and then solve for r.
Good. So I can use the -2, -3 as the hk, and I can use the 1, 4 as the xy and plug it in. So x minus h squared plus y minus k squared equals the radius squared, 3 squared, 7 squared, and I get 58 equals r squared, and then that can also just take the place of your r squared. You can do it either way. I don't care which way you do it. Just make sure at the end that your answer has just the h, the k, and the r plugged back in. All right, then we get to something like this where it says put the equation into standard form. So the actual instructions say sketch the circle given by the equation and then identify its center and radius. And to do so, we want it in standard form. So what's the way to get it into standard form? Compare this to standard form. In parentheses, we have, right, like x minus h squared. So I need to get these into perfect squares. How do I do that? We did it once with just a single quadratic. Now we've got to do it twice. I have to get each term to be a perfect square, right? So I'm missing stuff. Do you remember what that's called? We have to complete the square. Good. So I have to complete the square twice. Once for x and once for y. So I'm going to group them together. If they were not grouped together, I would group them together, rearrange them so they're together with their other variable. And I'm going to bump the 6 to the other side so it becomes negative 6. Now you get to complete the square not once, but twice. How do we complete the square? Yep. Good. Take the middle term, divide it by 2, and then square it, right? So 6, and I ignore the negative because either way I'm squaring it at the end, which will become positive. 6 divided by 2 is 3. Good, much more confident on that answer. 3 squared would be 9. So that's what I add inside the parentheses, and I have to balance this equation, so I'm going to add it to the right side of my equation. And then I have to repeat the process for y. So take 2, divide it by 2, and square it, and I get 1. I'm going to add it here, and I'm going to add it here. So I've just made those into 2 perfect squares, which I then have to factor. To do so, I square root the first term, I square root the last term, take the sign from the middle, which in this case was negative, put it in the parentheses and square it. Repeat that process for the y. Square root the first term, square root the last term, take the sign from the middle, put it in the parentheses and square it. And then negative 6 plus 9 is 3 plus 1 is 4. So here's the first step. Take that equation and get it into standard form. This will not be the only time you do complete squares. So if you're shaky on it, make sure you review some of that. You can go back to those videos or the supplemental material and go back through that. Now from here, in order to graph this, I'd need to know what the radius and the center are. That's the easy part, right? What's the radius of this? Radius is 2 and center is 3, 1. So whether you're putting the center in or you're taking back out, it's always going to be the opposite sign. And then I need to graph it. So I'm just going to loosely draw it for now, but obviously if I had this on a quiz or a test, you'd have a coordinate grid. 1, 2, 3, up 1. There's my center. And then I'm going to count up, right, left, my radius, which is 2. And then hopefully you could draw a better circle than I can. But it would be something like that. All right, then we've got x and y intercepts. So no matter what kind of graph it is, you find the x and y intercepts the same way, right? So whether this was a circle or a parabola or an ellipse or a hyperbola, you can always find the x and y intercepts the same way. How do I find x intercepts? Good. So for an x-intercept, I'm going to make y 0. And then for a y-intercept, I make x 0. Good. So let's start with the x. So I'm going to start by finding the x-intercept. I plug 0 in for y. And then when I go to square root it, what do I have to remember to do? Good. Plus and minus on the other side. So x minus 4 equals plus and minus the square root of 12. X equals 4 plus and minus 2 root 3, which is what square root 12 rationalizes to, or simplifies to. So there are two x-intercepts, 4 plus 2 root 3 and 4 minus 2 root 3. So you'll give me those intercepts as x, y coordinates. Make sure that it's not like x int is this, y int is this, or x is this, y is this, because you guys tend to confuse those things. Give it to me in coordinate point form. And then y-intercept. So go ahead, you find the y-intercept. All right, so you should have gotten 2 because when I go to square root 0, there's no such thing as plus or minus 0. It's just 0. And then add the 2 and I get 2. So in this case, you have 2 x-intercepts and 1 y-intercept. There's no fixed amount that a circle has to have. Could a circle have no intercepts whatsoever?
Yeah.
Think about what it would look like, right? What if I had a circle that was only there? Would it cross any axes? No. So it could have none, okay? Could it have more than 2 x-intercepts?
Yes.
Can it ever cross through the x-intercept more than 2 times?
Yeah.
No. It's only going to go like this, right? So the most it can have is 2. It doesn't have an extra wave that could go on the other side, right? It could have 1 x-intercept, 2 y-intercepts. It could have 1 y-intercept, 2 x-intercepts. It could have 2 of each, like in this case that I just drew, okay? It can't have more than 2, and obviously it can't have less than 0, okay? But any other combination of those, it can have. So if it helps you to draw it out to give yourself an idea of what it would look like, go for it. Like if I actually map out this, it's not hard to do. My center would be 4, 2, and my radius is going to be 4. So I could literally map it out and see that it crosses, and the one I just did doesn't go all the way over, but okay. If I did it accurately, it would hit at the exact right spots. And then also, if you're using this to graph, you would approximate what your square roots are, but if you're giving it to me as an answer like this one is where it just asks for the intercepts, I would obviously expect to see it left as 4 plus 2 root 3 and 4 minus 2 root 3. But if you wanted to use that as a graph, then you would just approximate what your root would have been. Like square root of 12 is in between root 9 and root 16, so I would approximate it to be like 3.5, something like that. All right, questions on that one? Okay, so that circles, and now we move on to parabolas, which we have spent several days and time on parabolas, but now it's different. So now we're talking about a parabola in terms of its focus and its directrix instead of its intercepts like we used to. We would do vertex and intercepts or vertex and points, or even shifts, okay? Now it's a little bit different. So we're going to start working with it in terms of its focus and its directrix. So the parabola is this set of all of the points in a plane that are equidistant from a fixed line, and that line is called the directrix. And a fixed point, which is the focus, which is not on that line. So in this parabola, which is just an example of one kind of parabola you can have, because we can have vertical or we can have horizontal, we can have opening up or opening down, right or left. But you've got your actual curve, which has the vertex, which we're used to, the point in which that parabola changes direction. And now you've got a directrix, which is a line that goes in the opposite direction that the parabola points. So a parabola can never cross through the directrix. And then you've got a focus, which is inside the parabola. So whether your parabola is pointing up or right or down or left, your focus would always be inside your curve. The midpoint between the focus and the directrix is the vertex, which means that the distance from the vertex to the focus and the vertex to the directrix are the same. We call that distance P, which we'll get to in a second. And then the last thing this mentions is the axis. So we have talked about an axis of symmetry before. The axis of symmetry is the line that is now going to be perpendicular to the directrix, and it runs through the parabola at its vertex. So standard equations of a parabola, and there's options here, okay? The standard form of the equation of the parabola with a vertex other than 0, 0 is written as those top two. So if my x is squared, which is the ones that we have been dealing with prior to this, which way can my parabola point? If the x is squared, think about the standard parabolas that we've been talking about. Which way do they point? Up or down, right? So this would be a parabola that opens up or down. If the y is squared, then it would open right or left. And we'll talk about how you can determine that in a second. So if it's a vertical parabola, then the standard form is x minus h squared equals 4p times y minus k. And again, p is the distance from the vertex to the directrix or the vertex to the focus. If it's a horizontal parabola, meaning it opens to the right or to the left, now the y is squared. So it's y minus k squared equals 4p times x minus h. The h always goes with the x, the k always goes with the y, but the location of the squared term, God bless you, whether the x is squared or the y is squared is what determines if it's vertical or horizontal. And then if the vertex is on 0, 0, this can be simplified to these formulas. Notice it would be like if I just lost the h, the k from both of those, it'd be the same thing. X squared equals 4py and y squared equals 4px. So in none of these can p be 0. That would say that there's no distance between the vertex and the directrix or the vertex and the focus, which can't happen because then it would cancel out your other variable. How many of you came from regular? Out of curiosity, from regular algebra 2? So in regular algebra 2, they actually switched these sides. The 4p goes on the other side with the squared, and it goes 1 over 4p, okay? Which can get confusing. So if you're remembering something like that, this book does it in a different format. I think if you came from honors, I asked Miss Ferrier today. She said it's like this. So hopefully it was consistent, where the squared goes on one side and the p goes on the other. All right, so this is what they look like. If it's vertical, meaning the x is squared, then it's going to point up, it's going to point down. So if it's vertical and the p, so this would be an x squared and a positive p, then it's going to open up. This would be an x squared with a negative p, that's going to point down. And then here, the other side would be right and left. This is if you have a y squared, and if it points to the right, it's got a positive p, and a y squared, and it points to the left, it's a negative p. All right, so you're going to get given pieces of information, mostly 2 of the 3 vertex, directrix, and focus. And then you've got to figure out your p-value from there. Then you figure out what kind of equation to plug it in, and then plug it in. So what you want to do, in my opinion, I would suggest mostly, is to map this out first. So take the information, give yourself a little visual. It doesn't have to be 100% accurate, but at least you'll figure out which way it's facing, and is the p positive or negative, and then go from there. So if I have a vertex at the origin and a focus at 0, 4, then it would look something like this, right? Vertex at 0, focus at 0, 4. 1, 2, 3, 4. So which way does this parabola face? Up. Remember, it's got to go around the focus, so it's going to point up. Which tells me which variable is squared. The x is squared. And is p positive or negative? Positive p. So already I've narrowed it down to that. The only other piece of information I need to know is the value of p. How do I get that? It's the distance from vertex to either directrix, if they gave me that, or vertex to focus, which is what they gave me. So I literally can count 1, 2, 3, 4, and p equals 4. And now I just have to plug it in. So I know if it's my x squared equation, that it is x minus h squared equals 4y minus k. 4p, y minus k. So it would be x minus, in this case, it's 0 squared equals 4 times 4, y minus 0. So I could have used my reduced format because this is a vertex at 0, in which I go straight to the x squared equals 4 times 4, which is 16y.
If it wasn't reduced, would you just give me like the 16 to the 1?
Nope, you would leave the number on the outside. So inside the parentheses is just the value of x and just the value of y. You don't want anything attached to it. In reverse, you're going to see in a couple minutes, in reverse, we would actually take something out if there was attached to it. So good question. Okay, so then the next one says vertex at the origin and focus at 1, 0. So this time, vertex still at the origin, but my focus is at 1, 0. So which way is this facing? To the right, which means which variable is squared? Y is squared, and is p positive or negative? Positive p, and the p value is 1. So I'd get y squared equals 4 times 1, which is 4 times x. Again, only because there's a vertex at the origin. Questions so far? Back on this while we're on it. Instead of the focus, you could have also gotten given the directrix. So let's say it said that you had a vertex at the origin, because in a minute we'll see one where it's not. Origin, directrix, y equals -3. So again, directrix is a line, right? Which means if I plot this and my vertex is at the origin, and a y equals -3 is what kind of line? Vertical or horizontal? Horizontal. So 1, 2, 3. This would be my directrix. That tells me this points in which direction? Up. And p, which means it's a positive p and an x squared. And p is what?
3.
Good. Distance from the vertex to the directrix or vertex to the focus. So it would be 3. So I'd get x squared equals 4 times 3 times y, or 12y. So if they just gave you those two pieces of information, then it will be ever changing. Sometimes you'll get the vertex and the focus. Sometimes you'll get the vertex and the directrix. Sometimes you'll get the directrix and the focus, in which you have to find the midpoint, right, to find the actual vertex. So you've got to know this stuff so well that you can manipulate all that different stuff. From that kind of question, it could say, what is the focus? And so I know I'd have to count up 1, 2, 3, and that would be my focus, which would be 0, 3. So you've got to be able to bounce back and forth between those three pieces of information to get the stuff that you need.
How come for A you didn't do x squared equals 4py?
I just said you could do it that way, or you could go straight to the reduced. So eventually we're going to get in a couple minutes you'll see a vertex that's not at the origin. So it doesn't matter which way you go, if you can go straight there or not. So go back to A, and where would your directrix be? Is it a vertical line or a horizontal line? Horizontal. Yep. Because P is 4, 1, 2, 3, 4, it would be down here. So if it asks for the directrix, it would be y equals -4. So directrix is a line, which means the answer is an equation. The focus and the vertex are obviously points. Okay, so what did I just give you? Let's say that I gave you the focus, right? Was 1, 2, and the directrix. Let's go a step further. Let's make it y equals 6. So I would want to, again, like for me, I almost, even if I could do a lot of it in my head, I almost always draw a picture, even if it's just a rough picture, because it's what helps me make sense of it. So I would do the focus, so 1, 2, is the focus. And then the directrix being y equals 6. So this is 1, 2, 3, 4, 5, 6. Now I've got a horizontal line that runs here. And I know that I know already that it's going to point away from the directrix and around the focus. So I already know that this is going to be an x squared and the p is negative. Does that make sense? So I have a x squared and a negative p, because I have to make it go down around the focus. And then from there, I have to be able to figure out where exactly lies the vertex. So the vertex, because I get given the focus and the directrix, is exactly halfway between them. So if I were to just count the 1, 2, 3, 4, the distance between the focus and the directrix is 4, which means the p is halfway between, which would be here. So p is 2, and my vertex is at 1, 4. It will, well, the p value itself, it doesn't really, as long as you're using p to count the distance, as long as when you plug it in the equation, you make it negative. So very rarely will you be asked for the value, like you're not going to write on that line like p equals whatever it is. You just need to know to make it negative when you plug it in. So now I've got an x minus h squared equals 4 p y minus k scenario, because my vertex is shifted. The x coordinate is 1. The p we just said has to be a negative and 2. And the y minus k would be 4. All right, now we're flip-flopping it. Now we're going to getting given the equation, and you want to find from it the vertex, the focus, and the directrix. Is this equation in standard form? No. How do I get it into standard form? What do we do with the circle? Complete the square. The good thing is you only have to do it once, right? The difference is that this time there's something attached to the x squared. So if you remember, you could go through the whole process of grouping this. So don't do it, but watch me do it. If I could group this, I would bring that positive 1/2 to the other side. So I'd subtract the 1/2. And then from inside the parentheses, that x squared has to be a 1, right? It has to be 1x squared, which means I'd have to take out what? A negative 1/2. I'd have to take out a negative 1/2, and then my inside would be a fraction. I'd be dividing the fraction by 2 and then squaring it. It gets ugly, right? But what's another way you could start this to get rid of the negative 1/2? Negative 2, right? Good. So I can start instead by doing that very first step by multiplying my entire equation, which means the y gets it 2, by negative 2. And I've eliminated that whole process. So I'd get negative 2y equals x squared plus 2x minus 1, and then start where I was before. So negative 2y goes to the left, x squared plus 2x, leave the space, bring that negative 1 to the other side, so it's now a plus 1 on the left-hand side. Everybody with me so far? And then I want to complete the square. So 2 divided by 2 is 1. 1 squared is 1. I'm going to add the 1 here and on the other side of the equal sign. So I get negative 2y plus 2 equals, I've made it into a perfect square, so I'm going to factor it. Square root the first term, square root the last term, take the sign from the middle, put it in the parentheses and square it. Now, how does this differ from my standard equation? That looks like this. It's switched, right? Which is not a big deal. It's still right. But maybe if you want to be consistent with what you know about the 4p being on the right, the 4p being on the outside, the parentheses, that you would want to switch it. So I could just switch it, put the squared on the left. And then this goes back to that question that you had, Nicole. There can't be anything attached to that y, so I would factor out the negative 2. So I'd get x plus 1 squared equals negative 2y minus 1. And now I've got an equation in standard form. which hasn't gotten me to the answer, but I have to do that before I can get there, right? Because the question is actually find the vertex, the focus, and the directrix. So from my standard equation, what's my vertex? That's the easy part, right? Negative 1, 1. Change the sign of what follows the x. Change the sign of what follows the y. How do I normally find or use my focus and my vertex? What's the distance between them? What's that value? P, right? Yeah. So how would I find P from the equation? What part of that equation is the P? The negative 2 is in the spot that we set equal to 4P. So then I solve for P, divide both sides by 4, I get negative 1/2. So I know my vertex is negative 1, 1. Based on my standard equation, what variable is squared? Which tells you this opens either up or down, right? Well, how do I know the difference? P is negative this time, right? Which means it's going to open down. So if it was a whole number, I could literally just like count down and up to get my focus and my vertex. It's a little bit trickier because it's a fraction, but it's the same process. So if I wanted to find the focus, I would be going down the distance of P, which means my x is not changing. My x is still negative 1, but my y just got decreased by 1/2. So if my y was positive 1, 1 minus 1/2 is 1/2, and that's my focus. So I basically just did K minus P because it's moving down. And then to find the directrix, I'd be going up 1/2, but this time it's a line. So if I take the K and I add P to it, I get 1 plus 1/2, which is 1.5. That's a horizontal line. Which would be a y equals 1.5 or y equals 3/2. Either one is fine. So if this was a parabola turned on its side, then I'd be affecting what? The x or the y? If I wanted to find the focus and the directrix, if it was turned on its side. What's going to change, the x coordinate or the y? The x. Does that make sense? So if it's vertical, the y is changing, right, because you're going up and down along the axis. If it's horizontal, the x is changing because you're going left and right along the axis. Questions on that one? Okay, last one, which I think is easier than the one before it. That's the good news. Find the standard form of the equation of the parabola with a vertex of 1, 3 and a focus of 1, 5. Try it. See if you can get how far you can get. Mm-hmm. So again, started by applying the point, vertex 1, 3, focus 1, 5, which means that this is a parabola that points upwards. That's a positive P on an x squared. And then I just plugged it in. This time I had a vertex change other than 0, 0. So I get x minus the h, which is 1, squared equals 4, which is what times the p, which is 2, and then y minus 3. Questions on anything we talked about today? So again, in a case like this, you'll be given 2 of the 3 pieces of information. Sometimes the vertex and the focus, sometimes the focus and the directrix, sometimes the vertex and the directrix. And then you've got to use your graph, or you could do it in your head. I just tend to think that it's a little bit more visual if you can draw it out. But some of you can handle this in your head, which is fine. And then plug it in. All right, so homework is published for this. Again, this was 9-1, and then we're going to do 9-2, and then we'll pause for a quiz on 9-1 and 9-2, which is next Monday. And then I'll probably go 2 more sections before a test, and we'll break it off at the end of the conics. We'll start parametric equations.